Hi everyone, welcome back to this channel. If you have been working with TypeScript for a while, I bet you find yourself wondering whether you should use a class or an interface. In today's video, we're going to dive deep into the key distinctions between a class and an interface. We're also going to see the best use cases for each. Let's get started. So the best way to understand this is that an interface defines a structure and contract, whereas on the other hand, a class defines structure and implementation with concrete behavior. Let's see an example. For example, I have an interface person. So using the interface keyword, we're basically telling the computer that an object that wants to be considered a person must have a name, with a name which is a string, an age which is a number, and a read-only ID property which is a string. And here the read-only keyword is a compile time check. It ensures that after initialization the ID cannot be reassigned. And we're also going to have our say hello optional method, and this basically specifies that such method might exist, but it does not provide an implementation. So this entire interface has zero runtime overhead. It's purely a compile time type checking. So now let's assign a JavaScript object to this. So TypeScript ensures its shape matches the interface. No special constructors, no new keyword, and also notice how the interface can even define function contracts, like our greater interface. When we run these codes, we are going to see only the console logs, not interface. So this proves that interface itself had no runtime footprint. Now let's see a class. Let's have a person class. So here we are going to define a person class. Also, as well, we're going to use the class keyword. The constructor here is what gets called when you create a new instance, and this public name, string, and public age number is the constructor. It declares that these are public properties on the class and assigns incoming constructor arguments to them. So this class, unlike the interface, will exist at runtime as JavaScript functions. We've added private secret ID property. So this is going to demonstrate encapsulation. So the secret ID is only accessible from within the person class itself, not from the outside. And then we have our greet method. This is where we're going to define the behavior or logic associated with the person object. And finally, static create method. So static method belongs to the class itself, not to individual instances. So you call them directly on the class, like maybe person.create, not on an object created from the class. So down here we initialize our person class using the new keyword, creating an actual Olga object. We can then call its greet method. And here is the key distinction. So when you do console.log Olga instance of person, this is going to output true. The instance of operator is a runtime check and only works with classes, confirming that Olga is indeed an instance of our person class. So you cannot use an instance of within an interface because they don't exist at runtime. So to recap, the fundamental difference: interfaces are compile time contracts, so they like vanishes into air in JavaScript. So classes, on the other hand, are runtime entities, so encapsulating both the data and the behavior. Let's accelerate into really interesting stuff. Interface merging. So this is a powerful feature, especially when you are working with external libraries or want to extend types across different parts of your application without direct inheritance chain. So if you define multiple interfaces with the exact same name, TypeScript is going to automatically merge all those properties and methods into a single unified interface. If I have an initial product interface, perhaps let's say it comes from a node module package. Now, imagine later in your code base, so you want to add more properties to this product. Now, we're just declaring an interface product. We're not using extend here in this context for merging. We're simply redeclaring. We've added price and an optional descriptor and a new method get formatted price. So TypeScript sees these two product declarations and combines them into one comprehensive product interface. We also included a quick example of a declare global block to show you how you can augment built-in global types like window within your own property. And just like that, our myProduct object must satisfy all properties from both declarations. So this is incredibly powerful for extending types from third-party libraries. For example, if a libraries are missing something you know exists at runtime, it's clean, safe, and does not involve hacking the original library types definition. Now let's see the most common use of interfaces. Using a class to implement an interface. So while the interface defines a construct, a class, on the other hand, implements that construct. It ensures that the class must provide concrete implementation for all methods and properties defined in the interface. So here we define the logger interface. It's a simple contract. Anything that wants to be a logger must provide log, warn, and error methods. Now our console logger class is going to implement logger. So if I were to omit warn or error here, TypeScript would immediately throw a compile time error, telling me that console logger doesn't fully implement the logger interface. So this is a powerful feature because it guarantees that any console logger instance will adhere to logger contract. We could also add another class, say remote logger, that implements same logger interface but extends log to a server instead of the console. So the beauty here is that we can type app logger as just logger, and it doesn't care if it's a console logger or a remote logger. It's just know that it can call log, warn, and error. So this enables flexibility into specific implementations. Going next to another powerful class feature is the abstract classes, and I like to think of abstract classes as a hybrid. So it's like a class that can't be directly instantiated itself. It's basically like incomplete, but it can provide some concrete implementation along with the abstract members that must be implemented by its subclasses. So we use them when you need to share some common behaviors among related classes, but still enforces that specific specialized method that are provided by the concrete children. So here we have a shape, which is an abstract class. It has a concrete name, property, and a constructor, and you can't say new shape. TypeScript won't allow it because it is meant to be extended. So most importantly, we have the area. It is an abstract method, so this means shape itself doesn't provide a logic for calculating an area. It only declares its signature. Any class that extends shape must implement area. However, describe, this is a concrete method. All subclasses of shape automatically inherits describe behavior, so this reduces like duplication and makes the shape perfect template for other geometric classes. And here, as you see, the circle extends shape, and it is forced by TypeScript to provide its own area implementation, but it automatically gets the describe method. So this pattern is ideal for creating the hierarchical when some behaviors is common into different children. Thank you. See you in the next video.